For this activity, we're gonna solve the XOR problem using the Python programming. Okay, so based on the understanding regarding the XOR, we know that if the different input will produce 1 while other is 0. So this is the table for the XOR. So we can see that if the same value, it will produce 0 output, while the different input will produce 1. So in the XOR model, we can see that there's input layer, hidden layer, and the output layer. So the W1 size is 2 to 3 due to the input size 2 and the hidden layer is 3. While for the W2 size, it's 3 to 1 as the hidden layer has a 3 size and the output has 1 size. For the first question, okay, so as we know, deep learning neural network are trained using a stochastic gradient optimization algorithm. As part of the optimization algorithm, it is necessary to estimate an error in the current model state repeatedly. This involves the option of an error function, generally referred to a loss function, that can be used to estimate the model loss so that the weight can be changed at the next measurement to minimize the loss. Okay, so the mean square error is calculated as the average square difference between the predicted and the actual values. The result is always positive irrespective of the sign of the expected and the actual value, and the perfect value is 0.0. So squaring means that larger error result in more error than smaller one, which means that the model is punished for making large error in the model so that the weight can be updated to reduce the loss in the next evaluation. So if we plotted the value of our loss function, we get the following plot. So after about the 8000 iterations, shows that our model have indeed converged. For the second question, regulation is an effective technique to prevent a model from being overfitting. It's allowed to reduce the variance of the model without a significant increase in its bias. The method allows us to develop a more generalized model even though only a few data points are available in our dataset. So, regulation can be achieved by introducing penalizing terms in the cost function which assign a higher penalty to complex curves. So the performance of a machine learning model can be evaluated through a cost function where it is represented by the sum of square and the difference between the actual and the predicted value. So this represent the predicted value. So this is the y hat, and this is the represented the actual value. So regularization achieved this by introducing a penalized term in the cost function which assign a higher penalty to complex curve. Okay, for the third question is to manage the noisy data. So to manage the noise data, okay, so we have several steps to overcome the noise. Okay, so the step 1 is the forward pass. So the forward pass is to make a prediction value. Okay, so the second step is to detect the error to be corrected. And for the step 3 is to update the weight value. So as you can see in the below, so as the epoch training increase, the training error will started to decrease until you can see that after the 8000, the training error getting smaller and smaller. So it means that the training error have been successfully training. So the after the training has been successfully training, so the updated weight 2 is equal to the previous weight minus with the error. Same goes to the weight 1. The updated weight 1 is equal to the previous weight 1 minus with the error. So so as you can see that, so we will make the prediction using the previous training. So after the training, so s equal to the 0 0 0 1 1 0 and 1 1. So this is the input for the y hat, or we call it the prediction y. So the prediction y, we will use the training value in the previous one. So as we can see that the 0 0 is equal to 0, and 1 and 1 1 is equal to 0. So while the 1 0 equal to 1 and 1 0 and 0 1 is equal to 1. So it means that the error has been successfully training through a repetition process. So this is the weight for this is the updated weight for the W1. So the W1, as we know, is a 2 by 3 size, while this is the updated weight for the W2, which is the 3 by 1. So this is the result for the, we can see that this is the table. So the gray one, the red one is for 1, while the gray is for 0. So this is the decision boundary of the weight after the training. So we can see that the blue one is for 0 and the green one is for 1. So this is the final result that obtained after the training error process has been done.